Hello friends, we got our question number 8 and this is different from the other one. And this is different in the sense that previously there we were getting here function in the term of e to the power x, but here function of x only, not e to the power x. When there is no e to the power x, then we will apply Euler theorem. As previously we have discussed like these two conditions when function of x has got two different form, e to the power x and not e to the power x. Then if it is e to the power x, then we are just using this formula which is common for both. But when this is not in the form of e to the power x, then there we are going to use three steps. For very first we will use partial fraction concept, then after we'll use this common formula, then after we're going to use Euler formula. Means where there is e to the power iax, we will replace that value with the help of sin and cos. Here let's move ahead. Finally this is our equation and which is in symbolic form, so it's auxiliary equation. We got coefficient of y equal to 0. On solving we got the value of d which is imaginary, so we got alpha and beta value with the help of which we can write our CF like this. After getting CF, the major concern is our PI. So PI equal to function of x divided by function of d, and our function of x is tan ax and divided by function of d, which was our this one d square plus a square. So we got our term like this, tan ax by d square plus a square, and we know we are solving this question by general method. So for that our denominator of pi, that is function of d, must be in factorized form, but it is not in factorized form, so we will convert it in factorized form with the help of the I concept. Means we will put there I and in front there will be minus, so I'm taking the square of I, there will be minus 1, so that minus 1 into minus is going to be plus and it will be the original form. So we will introduce there I so that it will be converted into factor form like this. Now it is factorized. Now we know that out of factorization we have to use our partial fraction concept, since right hand side is not in the form of e to the power x. So our tan x divided by factorized form of the function of d. And now on applying partial fraction concept, we got this term. When we separated this term, and to separate we need to balance this term, because when taking the LCM of denominator, the numerator is going to be cross multiplied, so 2ai will be extra term on the numerator, so to balance that we multiplied it with 2ai. So this is our partial fraction concept. As we have discussed already, here we will send tan ax to both of them, so that on separating we are going to get one term, two term, and it is similar like as pi1 pi2. Let this equation be our equation A. Here we are going to use formula. Which formula? This one, 1 by d minus m function of x equal to this one, as we have discussed already. So first we are going to solve for 1. So let's see this much. The coefficient we will see later on. Okay, so first let's solve this one because it is too complicated, so you have to focus on each step. Okay, so first we are going to solve 1 by d minus ai tan ax. So we will use this formula, then we will apply Euler theorem, where e to the power minus ax is replaced by cos ax minus I sin ax. Focusing on our this term only, we will apply our the formula this, so we got our expression like this. So it becomes e to the power aix integration e to the power minus aix tan ax. Look, up to here, we have applied partial fraction concept. Then we have used this formula 1 by d plus minus m, means this one formula we have used. Then after, the next step comes there, that is Euler formula. Means wherever there is EAI, there we will use this value. Means look, this one will be just like as multiplied form. This is no matter. But inside the integration, we will use Euler formula. Means here e to the power minus I ax. Its value will be cos ax minus I sin ax into tan ax. If you try to solve the integration by another method, you're going to be stuck very hardly. So we have introduced our Euler formula concept to solve this integration easily. So this is our final expression. And further, here we'll multiply tan ax to both of them. Means we'll distribute tan ax to both of these terms, sin term and cos term. So our new expression will look like this. So it becomes cos ax tan ax minus I sin ax. Tan ax, they are in bracket, so we'll convert our tan in the form of sin and cos. So on converting this, we are going to get sin ax by cos ax. Here also sin ax by cos ax. So cos and cos is going to be cancelled. Here only sin ax term will remain. And here sin and sin going to be in square form, they are in multiply form, divided by cos ax. And we know that there is no integration of sin square. So we'll try to convert it into cos so that it will divide from denominator, so that the square form will going to be reduced into linear form. So sin square ax is changed into 1 minus cos square ax, so that on separating the denominator is going to be sec ax minus a square and divided by cos. It's going to be cos ax. Then look what happened. There is no integration of sin square, so we change into cos square. As there was denominator cos ax, which divided the square term, and it is going to be in linear form. Now there is formula for linear cos ax sin ax or sec ax. So finally we got our three term like this: sin ax minus I sec ax plus I cos ax. This is plus in the sense that minus into minus, we got plus, and this is being copied as a multiplied from top to down. Then we know integration of sin ax is this minus cos ax, and if there is any coefficient multiplied to x, we should divide by that coefficient, which is a. Similarly, we got integration of sec ax is log sec ax plus tan ax divided by the coefficient of x, which is a. And similarly, integration of cos ax is sin ax divided by the coefficient of x. Up to here, I think every term is clear. Now we have to gather sin ax and cos ax at one place, so that we can again return them in the form of Euler theorem. So on gathering sin and cos at one place, we are going to get cos ax minus I sin ax like this form, and we have taken a common minus 1 by a from this both terms. So this term is going to be appear like our Euler formula of e to the power minus I ax. So we gather sin and cos at one place, so we can return the value in Euler theorem. So this become like this, and here this term is being copied as usual. We are going to open the bracket. Means if we open the bracket, then this is going to multiply with this and this, so that when it multiply with this, it's going to be e to the power 0. Means this and this bases are same, they are in multiplied form, so power can be added, and on adding the power going to be 0. So finally e to the power 0 means 1, so it's going to be minus 1 by a, and from both we are going to take common minus 1 by a. So the next expression will look like this. So just we are solving 1 by d minus ai and tan ax. So we got up to this expression minus 1 by a bracket whole bracket, and we got inside this much term. But there is still one of the term is remaining, that is 1 by d plus ai. So to get that value, we'll just replace I by minus I in this term. Then here will be plus and here will be minus I e to the power minus I ax, and other term are same. Means after calculating one of the term, just to get the plus value, we will replace I with just minus I, so we can calculate our both values. After this calculation, we are going to substitute this value in our equation A. So from our equation A, what was our equation A? This was this 1 by 2ai, and this value we just calculated, minus 1 by 2ai, and this value we just calculated by replacing I with minus I. So from this equation we are going to get this form. This is the coefficient which we have left here, and then this is the value of our 1 by d minus ai. Similarly, and this is the value of our 1 by d plus ai. As we can see our equation A, this is the coefficient and this is the coefficient. The both value, this value and this value, we are replacing, so we are getting this form, this and this, and this box has the same value, that is sec ax plus tan x. There was not a space, so I didn't copy that value. Then after unsolving, means from both sides we are going to take out common 1 by 2ai, 1 by 2ai, and minus 1 by a, minus 1 by a, so that on taking this both common, we are going to get this expression 1 plus this and minus this. From this both, on solving, 1 and 1 is going to be cancelled, and we can see from these two are leaving behind. So here log and the bracket value, log and bracket value are same, so we'll take that common. So I'm taking common, we're going to get this form, and again here we'll put the value of e to the power iax plus e to the power minus aix from the Euler theorem. So on solving the both, we're going to get 2 cos ax. Means we put the value of e to the power ix plus e to the power minus ix. So there will be 4 term, cos ax plus sin ax plus cos ax minus sin ax. So sin ax term is going to be cancelled, and we are going to get 2 cos ax log. This is the value of our this bracket. So final expression is our required pi, which we got from our equation A. So complete solution is equal to CA plus pi.